Hi, I'm Michael. I'm from Linz, Austria. I'm going to talk about DataChest today, which is a uniform interface to domain data. So it should make interacting with domain data easier for us JavaScript programmers. I work at Quasipartikel in Linz, which is an office sharing project we launched in 2008. And yeah, let's jump into the topic. I'm going to give you some background at first, so how this all started back in October last year. We'll cover the most fundamental data structures or concepts of DataChest, which are graphs, nodes, objects, and types. We'll have a brief look at the API. We'll cover persistence. So persistence is like a drop-in support. So you don't have to use it, but you can. So it will be possible to store data on a server-side backend without writing server-side code, actually. We will cover offline applications also. Then I will give you a demo of Substance.io, which is actually the application that drives DataChest development. So we'll have a look at this. And finally, we will build a DataChest client so that, to show you how the API works, basically. So as said, DataChest is developed in the context of Substance, which is a web-based document publishing engine. That's how it looks like. The idea was the following. Substance is dedicated to manipulating documents right in the browser. And as you know, documents are usually composed sequentially. Like you start on top, write your text, and do formatting to it to structure it and add styles and format. But the idea was to do that a little bit differently. So we split up this document into its integral parts, so to say. So we have at the top level the root node, the document content node, so to say, which then consists a section, an image, or a text node. So what we are ending up with is a data structure that looks like this one, which is basically, in the case of a document, a tree, but there could also be back references. So what we are looking here at is basically a graph data structure. And that's actually what DataChest is all about. It's an object model that sits on top of graph data. So graph data is a low-level data structure in computer science, and we built sort of an API or abstraction layer on top of it, so it's easier for us to interact with it. DataChest is in-memory data manipulation. So you're basically manipulating and interacting with a local in-memory data structure, which can then be persisted to the server at some point. So that's the persistence layer then. It provides the exact same API on the server side and on the client side. So you can reuse code you've written, basically. It also features a query interface for local and remote data. This library is inspired by the concept of the Semantic Web, which is basically also based on graph data. So you know the resource description framework that sort of acted as an inspiration. And there's this project, freebase.com. I don't know if you have seen this. They have been acquired by Google lately. They also use the concept of semantic web, but they stripped it like down to a simpler API, which is JSON-based on not this XML stuff. I also took some inspiration from _JS. So where are the use cases? You could, for example, build data analysis and visualization tools on top of this DataChest framework. So I don't have enough time to show you this project live, but what we see here, you can check it out yourself then. What you see here is a visualization that shows that aggregates and filters data that are pulled from GitHub, and it's aggregated, it's represented as data objects, this data from GitHub, about top 1,000 Node.js repositories, and the filtering and the aggregation is performed in memory. So you click on a certain aspect of the data, and you immediately see the results. So check it out. As said, it could also be used for offline applications. There's an example at tasks.substance.io. So you can check out that as well. So this deals with the problems of offline applications like synchronization and conflict management. So let's have a look at the anatomy of a data graph. It basically consists of data nodes, which can either be an object or a type. So data nodes are then connected through properties. So they reference each other, basically. Each data node has a type property, which describes which type, so to say, which class it is a member of. In this example, we've some example data from a document model, and we also include a user data structure here. So a document has a creator which points to a user object in the graph space. Also, it contains a section or more and connects this with the children property, which is a non-unique property, which means it can have more than one value. So all data nodes in the graph share a certain set of properties, which are the ID property, that is a unique identifier, which is either be generated or explicitly set by the user. The type property is also recommended. So this depicts of which type the node belongs to. So that need to be filled out too. And we have a ref property, a revision, which is used for detecting conflicts in a persistence scenario. So this is how a data type looks like. It's the JSON representation, basically an object literal. You have to specify an ID, type property, and in the case of a type, you need properties property, which describe the abstract characteristics of objects of that type. So in this case, we have a section, which contains a name property, which is a value type string, and the children property, which can either be a text or an image. So here's an instance of this type, so to say. It's a concrete section, which has a name, and a children property, which refers to an image. And it has a link to the associated type, which is type section. A data graph is constructed by calling the data graph constructor and pass it a serialized data graph, some seed data to initialize the data structure. Basically, you insert some schema information here, but you can also combine it with objects. When you've done that, you are ready to add objects to the graph, which is as easy as calling graph.set and pass it an object represented as a JSON object. In this case, we just add a new text node. We can then set properties on an existing object. Therefore, we need to just pull it out of the graph at first, which we do with the graph.get call. We then are ready to call we get back a reference, a section reference in this case, and we can call section.set and set the children property. In this case, we add a text object that we have created earlier. At some point, we are ready to synchronize our local data structure, which has some dirty nodes that we've changed and other ones that have not changed yet. So it should just synchronize the dirty nodes. We just have to, from a user point of view, we just have to call graph.sync. So that's how graph persistence basically look like. So we have our in-memory data structure on the right side here, the client. And on the server side, there's the huge graph with all the information from all the users, so to say. And we are talking to either a graph read service or a graph write service. So if you have changed two nodes, we just synchronize those two dirty nodes and send them in one go to the server, which is a Node.js backend. It then gets passed through a filter stack that you can apply, and it ends up in CouchDB. So one node in the local graph later on corresponds to one document in CouchDB. So this is how it's basically working. And we have a quick look at how filters work. So in the case a user is trying to save two nodes, one of which is a section, and the another one is an image. We'll go through the authorization filter at first, which detects that the user session is not authorized to save the image node. So it will be rejected. The section node passes through and goes through the sanitization filter, for example, if you want to strip HTML code that could be injected and could be used for cross-site scripting. So you're going to change this node and pass it to CouchDB then. The next release of Data.js is dedicated to offline applications. So with Data.js 0.5, there will be the feature of bidirectional sync. So we're going to use a pull-push approach here, so that if you have your local graph data structure, you can, as soon as you click sync, you get back updates that have happened on the server in the meantime. And those nodes then get merged into the local graph, which can result in conflicts if you have changes locally as well. So that's the hard part, basically, in this offline application scenario we all have to deal with when we want to build these apps. And yeah, Data.js is going to be using local storage for keeping local data persistent. And this is how we are dealing with conflict management. Suppose the following scenario, two clients check out the same node, say a text node, and start editing them. So chronologically, the first client changes this node, it gets dirty. Then it will be synchronized with the server, which is OK. You see this on the left side here, the client 1. Since the client 1 specified the right revision, which is actually the latest revision on the server, it goes through, and the client gets back the updated node containing the new revision, which is revision 2. The client 2, on the other hand, in the meanwhile, so to say, also changes the same node and hits the synchronize button, but he's the latter one. So there will be a conflict here. So what happens then in the Data.js case is that the server returns the newest revision it knows. And the client then have to deal with this conflict scenarios. He has to resolve the conflict himself. So basically, you have to implement a merge strategy to deal with this certain scenario. After it has been resolved by the client, he can either use his version or the version that was on the server, and then start another sync. And this is on the right side then. It gets back to revision 3, and it is fine again. OK, I'm going to show you a project I'm working on since last year, October, which is basically that one that drives DataChest development, as said. And it's basically open document authoring and publishing for the web. And open means it's a fully open source effort, so you can check it out. It can be used for free. And it targets open collaboration, so it encourages readers to contribute to documents easily. So let's have a look at recent documents here. There are a lot of Hello World documents already. This one is a nice one. Dan Halliday, he used the Substance editor to make a write-up about the musical composition, and he added some transcripts here. So that's a nice example. But what we want to look at is how document manipulation looks like. So if we want to add a document. So let's go here. And this is actually the presentation we were looking at before. It's basically a Substance document that is being translated into a slideshow on the fly. So what we can do here is change something. And if you look at the upper right corner, you see a spinning wheel there. So if you manipulate the local data structure, the local data graph, at some point a synchronization gets triggered and the changes to the document get synchronized with the server. Yeah, we're pretty far yet. You can invite other collaborators by specifying an email address, so it gets a link that can join the document creation process. We've built versioning, so now it's time to publish this this document. So it is available to you right now. So if you are going to the Substance.io platform and click on the recent documents panel, it should be available to you. But you're probably not interested in looking at the Substance representation here. You're gonna see the slideshow representation. And for that, you can use the export dialog, and there are many formats that are already available. So we use asset substance exposes documents as data, as a data graph, and an external service, in this case, it's called letterpress, which is the conversion service that turns substance documents into arbitrary other formats. We've implemented some predefined output formats, which are run through Pandoc, which is pretty good for cross-document compiling, so between formats, so to say. Okay, and here's the shower representation, and we are back in our slides. Yeah, so you are invited to try out the Substance, the Data.js API, and that could be done by just consuming the Substance API and building a client using Data.js. So all you need is basically a static HTML file and the Substance, the Data.js library. So what we are going to do is first connect to a remote data graph, fetch a document, and render it. So we are going to construct a new data graph, pass it a schema, which is available in Substance. You connect to a remote backend using Ajax in this case, and you specify a URL where this service lives. You can then start fetching a document by specifying a query object and pass it to the graph.fetch method. And you get called back as soon as the result is there. And we are interacting with this nodes collection. You can just ask to get the document, the ID you specified before. And once you've done that, you can walk this graph, you can traverse it by using the get API. So we have doc.get children, get the first children, get those children, which is a section, obviously, and get the first text element of this and its content. So what you then have to do is creating an HTML renderer, which you pass the document reference and call render on it, for example, or you can do it differently. And then you're ready to inject this generated HTML to your website at some point. So there are some examples for Substance integration. Max Ogden, he started to write his blog using the Substance platform and integrates his website with the API. And that looks pretty nice, I would say. So that's him. There's another one. Mario Schelliger, he's here from Berlin. He contacted me and he wants to use Substance for creating a community-driven book. And so we started to sketch something that is basically a reader of Substance document as well, but optimized for looking at it as it were a book. So we have these chapters on the left side. You can navigate through it. It's basically stripped down to a minimum. And we can, as a reader, just get active and discuss certain text fragments on the Substance platform. So should be easy to contribute, and you should no longer need to write an email to the author and coordinate this. So you just add a comment to this. Yeah. That's basically is it. So I would like to say you're invited to check that out. Try out the Substance.io platform. Try out Data.js, and start implementing your own application. These two projects didn't have get any funding yet. We applied for a grant in Austria, but it got rejected. And yeah, just check it out, contribute to the source, or if you can afford it, we are open for donations, which you can send to contribute at Substance.io. Or if you have any questions, just ask me afterwards, or send an email to info@substance.io. So are there any questions right now? Yeah.
Yes, from the perspective of DataChest, it's not loud enough. Can we repeat the
Yeah.
question that I sent with the microphone? So this type system with document, section, image, that's just one example.
That's one example, exactly. Yeah. Yeah. The question was if there's if this document model we've seen is just an example, and yes, it is. You can basically build whatever application you can imagine. So you can specify your own data model, which may be a project that contains tasks, for example, or whatever. So that's basically for building applications of any kind. Yeah.
And are there mechanisms to enforce this type system when I store my data? Is the data validated when I store it? And do not need the...
Yeah. The question was if there is a method of validation, and yes, there are some basic tools to do validation on it. You can specify a required property, for example, or you can specify a validator regular expression to make some checks. That's now supported. But you can also use a middleware on the server side to do more complex stuff of validation and reject nodes or something.
So that's a free schema. You define a domain by the schema.
Yeah.
And this HTML renderer, for example, that just assumes that you're at the schema you're using.
Yeah. Yeah. Your renderer somehow needs to know how the structure looks like, but yeah.
So you build that renderer with one schema in mind.
Yeah. You could. You wouldn't need DataChase at all for rendering this document. You can just take the JSON and use Ruby or whatever you would like to. Yeah?
Is it also possible to do this validation in the client-side part of Data.js? So even before I do the synchronization, because maybe I just want to create lots
Yeah.
of data in an offline client and then put it
Yeah.
to the server, to already validate while it's created.
The question was if DataChase can validate this on the client side, not at the server side. So yeah, basically it's done on both sides. So already, so this validator or required properties are checked locally and they are immediately rejected. So yeah.
And Data.js or relations between several document graphs.
Yeah, so the question was, can DataChase resolve associations between objects? And yeah, that's basically what DataChase is about. So to give you an API that makes that easier, so you just can call get and get references back, which are wrapped in a so-called data hash, which is also part of the framework. And yeah, so DataChest is used for traversal then.
The question was more about not about object properties, but about several documents. Do we store any relations?
Between documents. I don't do yet, but that could be done too, yeah. So it's some sort of how you index it or something. Yeah?
Where do you see JSON schema fit into that? Or have you looked at that or
Yeah.
integrated that?
The question was if I've looked at JSON schema and how it compares to that. Basically, it's a competitor. So I've had a brief look at it, but I was somehow more influenced by the MetaWeb object model, which is used at freebase.com, and so I tried to apply these rules there. Yeah. Yeah.
Is there some sort of event limiting mechanism which informs if I write a client and now the changes are pushed from the server to my client? How am I
Yeah.
informed about the changes?
The question was if there are events triggered, if some actions happen, like there's a new node that gets pushed to the client. At the current version, at the moment, we just support push support. We just support push mechanism, and basically when you manipulate a document, a dirty event gets triggered, and you can bind on that one. So, sorry. There's a dirty event that gets triggered when you manipulate documents locally. So there are some events for different scenarios.
So if another client manipulates the document that I also have checked out, then I'm informed by some sort of event.
Yeah. Yeah. Good question. And this is a work in progress, and it's all should be solved with 05, with version 05. Yeah. So that's on the list. Okay. Yeah, then, thanks.